So the question I have is this the gate array motherboard or the non-gate array motherboard? I kind of guessed in a previous video that because there's some PALs here, which are programmable logic, that it was a gate array board, but that's not necessarily true. And what I always do when I tackle a project like this is I go find the manuals and I print them out and bind them. And this binder here is all the pictures and schematics, etc., out of the Model 4 and 4P gate array manual. And actually, I flipped it open right to the right page. So this is the PCB. Let's get one page back from that. There it is. There is the silk screen for the standard non-gate array motherboard. Let's see, it is 8709427. This is a Rev PF3, it looks like, or PP3 maybe. No, that's a connector number, I do believe. So what? Anyhow, this has got to be a non-gate array, which I find interesting. Kind of looking at the schematic here. U126, 127, and yep, so I don't know how well you can see this or not, but U126 and 127 are these two PALs. There's three more PALs up here. It's definitely a non-gate array motherboard, is the point here. So now I know. Let's go ahead and find the gate array silk screen. This looks like it's right here. And let's see, let's get it oriented the same way. It should be, in this case, like so. And obviously a large amount of difference. Yeah, definitely not a gate array motherboard. There'd be a 40-pin package here. There'd be two 40-pin packages up here. Yeah, very different. Definitely a lower count, device count, it looks like. Okay, so PALs does not mean gate array motherboard, but this is good to know. So we believe this board is functional based on the little bitty bit of testing I did earlier. It's probably creating a bunch of glare off that plastic cover. Sorry about that. So non-gate array standard motherboard. Again, I don't know exactly what revision that really is. Maybe it really is revision PP3. This connector's J6. Huh? So it looks like it's revision PP3, whatever the heck that means. I see. We saw earlier, there's definitely rework. The wrap wire kind of added in here. I'm guessing it saw a ROM update. That part number there is probably the Tandy part number. I should look that up, 8075732. Should probably look that up and see what revision of the ROM that is. I'm guessing this was potentially a Tandy update, and they just went from some kind of a mask ROM to an EEPROM. So I thought we'd take a look at some of the components actually on the motherboard, at least some of the major components. So here we see the entire Model 4P. This is the non-gate array motherboard. We've got our PAL devices sitting down here. 4 of them are labeled. 1 or 2 the labels come off of, but those are the PALs. So let's take a look at these first 2 chips right here. So if we look a little closer, we can see that one of them is a TR1865. That is a UART, Universal Asynchronous Receiver Transmitter. This is part of the RS-232. It's what takes the parallel data and converts it to a serial data stream, RS-232 stream, or back from the serial RS-232 stream back to parallel data so the Z80 can deal with it. There's the boot ROM over here, and what's interesting in my machine is there's a 2732. You can kind of see the part number along down here, and it's part 8075732, which I can't find any reference to. If we take a look at the 2732 here, we can see, looking at the pins up here, that pin, what is that, 2432, pin 21 and 18 here have jumper wires on it. You can kind of see here where pin 21 has this blue lead coming off, and that blue lead picks up A11 from the motherboard, and the red wire here just grounds that pin. And so if we look at the pin out of a 2732, we can see that pin 21 is A11, which makes sense with this wire going off to A11. And if we look at pin 21 on the original ROM, I know I had spotted it here earlier, or no, A11 was pin 18 on the original ROM. So the 2732 is close, but not an exact drop-in for the original 4K ROM. So that's why there's a jumper to pick up A11, because originally A11 would have been on pin 18 here. Then pin 18, of course, on the 2732 is chip enable, or maybe is E output enable, or I don't remember, but it's one of the two enable pins. And in this case, that pin is jumpered with a piece of red wire down to ground. I'd have used black here personally, but whoever did the work did it the way they did. So that's taking this enable right here, and then pin 20, which is the actually enabling the device to be on the bus, is the same as this pin 20 right here. It goes low to enable the device. So this was basically bend these two pins out, two jumper wires, to use a 2732. If anybody knows what this Tandy part number is, 8075732, leave a comment and let me know what it is. Like I say, I've searched for it, I don't find it. I've been through a couple of pages that provide checksums for the ROMs. When I get the machine booting, I will checksum this ROM. But there's a look at the UART and the boot ROM. We move on now to the floppy disk controller. This is an FD1793. It's a pretty standard floppy disk controller, single or double density. And not a whole lot else to say there. It is the floppy controller, obviously, for the Model 4P. We've then got a part here, which will be the dual baud rate generator. So this part generates baud rates for UARTs. And this happens to be a dual baud rate generator. So it's generating, whatever baud rate the serial port is running at. We move on to a little 8-pin dip up here. And that's the floppy disk data separator. So it does exactly what it says. The data is coming off the head, and the data stream itself needs to be separated out from all the information coming off the disk. And that's what this chip here does. We move down here to the Z80 processor. In this case, we can see it's an SGS part made in Italy. It's a Z80A CPU, so it's a 4 megahertz CPU. Really, any Z80 4 megahertz part would work in here. We're going to move down here to what I believe is the video RAM. There's a little 2K by 8 static RAM down here, which, like I say, I believe is video RAM on the machine. I don't know that for sure, but that's my guess. I haven't actually researched it. We move down to this ROM here, and notice that this ROM here is near the video RAM, which is why I think this is video RAM, and that this is the character generator ROM. So this is the Model 4 US character generator ROM. Standard Tandy part number on it up there. We come up to the bank of 16 parts up here. Obviously, those are the system DRAMs, and again, they are Tandy marked parts, 8040665. In researching this, they are 200 nanosecond 64K DRAMs. There's 128K installed on this board. Last thing to kind of look at here is you can kind of see it in the photo here. There's some rework been done here. There's some wrap wire on the board. And a little closer look at this, and sorry the picture isn't great, is there's just green wrap wire. There's a jumper between those two pins. There's a jumper that comes off and over to a pin here. Something's being jumpered to ground here. Anyhow, you can see this. I'm going to go through and kind of document this, see if I can figure out what it is. I don't, in the photo it's hard to see if there's any trace cuts. I just don't know what this is. Maybe it's factory, I don't know, but you know, it is what it is. So that really, I think, is the entire look through the major components. There's a few other things I guess we could point out. There's of course power, video, and what's the third connector here? I don't remember at the moment. Connectors that run off into the system are down here. This goes to the floppy drives themselves. So there's ribbon cable that comes off here to the floppy drives. This is where the keyboard connects in. The keyboard cable comes in and gets connected to here. I'm assuming this oscillator is what ultimately produces the 4 megahertz clock for the Z80, which is sitting here. That would make sense to me. Although there's a 4 megahertz crystal sitting up here, which may ultimately become the Z80 clock. I just don't know why there's a crystal oscillator and a regular crystal up here. I'd have to look. This appears to be a resistor pack. It's actually RP1, so it is a resistor pack. Bunch of glue logic. It's interesting that some of the buffers are actually in sockets. So some of these, what are they, 20-pin devices that are 244s, 245s, that kind of stuff. I think that's a 3 or it's a 240, are sitting in sockets for whatever reason. Maybe they were expensive at the time, although I don't think so. Parallel printer, system expansion, RS-232. Don't know what else I can say about it. You know, there's my board. And with that, I guess we'll wrap this one up, and I'll see you in a future video.